Welcome to Space News from the Electric Universe, brought to you by the Thunderbolts Project at thunderbolts.info. Well, I think it's fair to say that when it comes to conditions at the center of any galaxy, some of the most interesting data has to come from our own celestial neighborhood in the Milky Way. I remember last year we reported on the, quote, shocking discovery that low-mass stars were forming just 3 light-years away from the hypothetical supermassive black hole at Sagittarius A. And in fact, I have in front of me a quote from a phys.org report on that discovery. It states, "At this distance, tidal forces driven by the supermassive black hole should be energetic enough to rip apart clouds of dust and gas before they can form stars." But since the black hole's non-existence is not, and has not been for a very long time, on the table as a theoretical option for astrophysicists, this type of discovery, like countless others, is simply forgotten, or at least no emphasis is placed upon it. So what are your thoughts on some of the best evidences in the Milky Way which tell us that it is a plasmoid and not a black hole at the center of the galaxy?
The stars that orbit that so-called black hole in Sagittarius A star do so very rapidly, which suggests, if you're using gravity in your equation, that the mass at the center of the focus of that orbit is of the value they give, millions of suns, or maybe even billions. And that's only because they're using the wrong force. We're talking about electromagnetic forces. The other thing is that, as was pointed out, I think by Ed Dowdy, who's done valuable work on looking at so-called gravitational lensing, and pointing out that it doesn't make sense. He said that stars orbiting that black hole, particularly ones that may have an orbit that's tilted and passes either behind the black hole or very close to behind, should suffer gravitational lensing. I've seen no evidence of that in any of the telescopic observations of the Sagittarius A. And they've been following them now, so I think they've managed to observe a complete orbit of at least one star, possibly more. The other thing was that there was a report of a cloud of material that was due to be sort of torn to shreds as it went close to the black hole, and that didn't happen. Well, of course, we're not dealing with gravity, we're dealing with electrodynamics, which is at the heart of real physics. That's the fundamental physics of the universe, is electrodynamics. Gravity is merely a minor effect. We happen to live in an electrically neutral environment where gravity does have an effect that is noticeable. But even for us, it is so weak that the entire Earth can't stop us from jumping away from it, even if only for a second or so.
Well, one of the most important phenomena we've talked about for years on Space News is the pervasive filamentary structures, which we see everywhere in the cosmos. Filamentation, of course, is produced by electric currents traveling through plasmas. And on the question of what lies at the center of the Milky Way, over a year ago, we reported on the discovery of a 2.5 light-year long filament, which appears to reach directly to the center of the Milky Way. So how does this discovery relate to the plasma cosmology theory of a plasmoid at the centers of galaxies?
These filaments, and some of them are twisted, I believe also. They've seen a twisted pair of filaments heading into the Sagittarius A star region. The circuit that Hans Elfvén drew all those decades ago, the Nobel Prize-winning plasma physicist, showed that the current, it has to be a circuit. If you've got an electric current, it must be part of the circuit. And he showed that the current would flow in along the galactic arms to the plasmoid in the center, and then out along the spin axes. And then at some distance, he didn't go into where the circuit was completed, but it was at some distance from the galaxy. Now, since he put forward that circuit, it's been discovered, of course, that galaxies seem to align their spin axes along what you might call cosmic strings. And they're beginning now to be able to map these strings and these connections between galaxies. Now, none of this makes any sense from the gravitational point of view, because gravitational forces are centered on a center of mass, not along a line, which a filament is. So both Hansel Fane and Halton Arp, in his observational research into galactic forms and structures and behavior, all coincide and form the basis for electric universe cosmology. The very idea of curved space, or space-time as they call it, he have attached two words together with a hyphen. Both of them are merely concepts, they're not physical things, so how you curve non-physical concepts is a question that is not answered. And we're shown diagrams where you have a heavy object on what looks like a rubber sheet being deformed, the rubber sheet being deformed by the weight of this object. But that uses gravity to explain gravity or to describe it. And it doesn't make much sense if you think about it. Deleting the force of gravity raises the simple question, well, what is it that stretches the spring on the balance that measures the kilo of potatoes? That is a force. We feel a force. We're very well aware of it when we fall over. You cannot just make it a trick of geometry. So that's the first problem. The major problem with black hole theory and the Big Bang is this idea that you can have a concentration of mass or energy at a point. Well, a point is non-physical. No physical object, not even a subatomic particle, can occupy zero space. And yet we see all kinds of mathematical concepts being put forward as being physical. And this has created huge confusion. In fact, the language has become largely meaningless, even more so when you consider that there is no physical definition of the quantities mass and energy. There is no physical definition. Mm-hmm. Now, that means we don't understand E equals mc squared. So, come on, Einstein, tell us what you meant. Explain it. Nobody can explain it at present. No physicist on Earth can explain it because they haven't defined their terms. And the problem has been the dominance of mathematicians in physics rather than physicists and what we call natural philosophers. Mm-hmm. Those with a broader education, the ones who got us through the 19th century with the huge number of developments, which actually brought us to the brink of the electric universe model in the 1870s with the Germans, Wilhelm Weber in particular, and his electrodynamics law. That you don't hear about that. I never heard anything about that at university. And when you look in the textbooks, you won't find anything about it. We are not given ideas to compare and think for ourselves. And that is the failure of education these days. We're just given things to remember and facts which are not facts but conjectures quite often. The result is that you are unfit for the job once you leave university. I've said this before, that electrical engineers are the ones who should be doing astrophysics because it is an electrodynamic universe. It is not a gravitational universe.
Well, of all the issues we've talked about on Space News, I think the most powerful evidence for cosmic scale electric currents is, of course, cosmic magnetism. So when it's not technologically possible to directly measure electric currents, the way that scientists can infer their presence and their strength is indirectly through the magnetic fields that they must produce. So at every opportunity, I remind the audience just how recently mainstream gravity-centric cosmology downplayed or even dismissed the idea of cosmic scale magnetic fields. Here, for maybe the third time, I'd like to read this quote from the 1999 online NASA feature, which asks the question, do magnetic fields exist throughout space? And it states, on the cosmological scale, there is no data to suggest that magnetic fields are present. They certainly are not important in the dynamics of the universe for any reasonable range of field strengths consistent with present observational constraints. So, why don't you discuss what has actually been discovered about cosmic magnetism and why it's so important for the electric universe and plasma cosmology?
Now, one of the beliefs that's inculcated in students and postdocs as well, at all levels in astrophysics, is that electricity plays no particular role in the universe, which is quite incredible when you think of the use we have for electricity, that the universe has no use for it. And when you map magnetic fields, which the radio telescopes have done for decades, and more recent telescopes have been built which are able to do it even better, they find that the universe is almost, in fact, they've come to the point now where they think that magnetic fields play a large role in star formation, because they've been able to map the magnetic fields in star-forming regions inside molecular clouds. Now, this kind of modern observation technique is showing more and more often the fact that magnetic fields are everywhere. And not only that, they are structured. They're not chaotic, which is what the gravitational theory would have us believe, that it's shock-induced chaos and whatnot, but they find ordered fields, particularly around spiral galaxies. And you do not have a magnetic field without electric currents. Electric currents are absolutely necessary because you need an accelerating force on a charged particle to generate the magnetic field. And the ordered magnetic fields indicate ordered electric currents, all of which matches the filamentary nature of the universe, which has also been discovered